we have to solve this problem and justify our steps. So how are we going to get rid of those parentheses? Yeah, so our first justification is that we're allowed to do this, boop, boop, and change those signs in our parentheses because of the distributive property. Okay, what about the next one? I like to look for what's different. So did the 7 and the 27 change?
No.
Okay, but we used to have negative 6a on the right, and now we don't anymore. So what happened to get rid of the negative 6a? Yeah, it got added over. So which property is that? Yep, the addition property of equality. Okay, what about the next step? Yeah, we're going to subtract away the 7 from both sides. That's our subtraction property of equality. What?
That's the EOC card, right?
Okay, what about the last one? Yeah, division what? Yes. Okay, that wasn't so bad, right? Okay, when we first saw this, this was very nearly impossible. But now you guys are like algebra weapons. Like you've survived unit 6. You know what I'm saying? You survived unit 4. Like this is not so hard anymore. So for solving for g, we're getting g alone. So these are all being multiplied together. So if we want to undo the multiplying that's happening with the 5 beta and the g, I have to do what with the 5 beta? Yeah, divide. This used to just blow your guys' minds. You've come very far. Okay, these cancel. They simplify to 1. And then 1g is just g. So over on the left, I have m divided by 5 beta. Okay, this one was even worse. This one really put a stick in our gears back in the day. We have to get y alone. If I want y alone, do I want x's over there with y? Okay, how do I, right now they're being added, right? It's a positive 2x. How do I undo adding 2x? Subtract it away. Will I be able to combine it with the 9? Because they're not like, okay, so I have 3y now equals 9 minus 2x. Now what? Divide by 3, good. All right, that gives us y alone. 9 divided by 3 is 3, but the 3 is also dividing the negative 2x. Does 3 go evenly into 2? Do they have any common factors other than 1 to where I could simplify it? No, that's a common multiple. So I'm looking to see if I can reduce that fraction, or do I just leave it as negative 2/3? Okay, so I'm just going to leave it. And then that's the coefficient for x. Now, what form do we typically want this equation in? Nope. Y equals mx plus b, slope-intercept? Anybody? Anybody? So is the 3 the m, or is the negative 2/3 the m? It's the negative 2/3, so I'm going to have negative 2/3 x plus 3. And I'm donezo. Okay, I want you guys to do number 4. All on your own. Okay, so which one did you guys pick? A, the one where the p is getting divided by the 2 and the pi. That is correct. All right. See how much easier it is now? Okay, I want to see if you guys can get this one. I want to give you time to read it and think about it. Okay, did I give you enough time? What are we thinking? Okay, so for these, it might help you if you labeled these. Okay, so if it's in 18 days, she can read 5 books. How many books can Betty read in 30 days? Okay, this one, I don't think this was it. You see how it's all like shuffled up? Okay, so what about this one? We've got in 18 days, she can read 5 books, and in 30 days, she can read how many books? You see how it's like days, books, and they line up nice and neat? That's the winner right there. Any questions? Did you guys get B? Okay, perfect. All right, what about this one? If we have this inequality, how can we decide if 3 is a solution or not? Okay, we can plug it in. Some kids always forget that they can plug it in and want to solve it. Can we solve it and see if it's a solution? Yeah, it just might be a little bit more work. Which way do you guys want to do it? Plug it in? Okay, let's do it. So we're going to take the 3 and we're going to substitute it in wherever we see the x. So I'm going to do 7 times the 3 minus 11. I want to know, is that less than 4? I don't know, so I'm putting a question mark. Okay, 7 times 3 is 21 minus 11 is 10. Is 10 less than 4? No. So we're going to say 3 is not a solution. Because why? Right. Did it make our inequality true? No. It made our inequality false. Oh. Okay, is it all coming back to you? All right, what about this? I think you guys can do this one. They're pretty much all the same except for what? The symbol. So basically we're looking for like, which symbol do we pick? But if we're only trying to pick the symbol because they gave us the rest of the inequality, what are the key words that we're looking for? Yeah, like only. Okay. So can she go over 46? Can she go under? Okay. Can she spend exactly 46? All right. So which one did you guys pick? Good. That's what I would have picked. Okay. The circles are just going to be gross. All right. What happened here? I'm going to give you guys a second to look at it. There's a mistake. So let's fix it. That is correct. So right here, after we divided by the -9 of both sides, we should have flipped the inequality symbol. So didn't flip inequality symbol. All right, let's fix it. So we've got 5 minus 8x is less than or equal to 2 plus x. Okay, we're simplifying. We've got -9x is less than or equal to -3 after we do our inverse operations. And then we are dividing both sides by -9. Okay, dividing by a negative number or multiplying by a negative number changes which side is the big side. So it changes the directional relationship for our inequality. So we have to flip that symbol. Okay. Questions? All right. Guys, we are cruising. Okay, so the tricky thing about this one is that we have now done systems. So it might be a little bit tricky to like put your unit 1 hat on where we didn't write like y equals yada 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 yet. We just wrote one big equation with only one variable. You guys remember that? Maybe, maybe not. For the let statement, remember we're looking at the question. What is the question? Good. So what does x have to be? What are we finding? Years. X has to be years. Okay. So we're gonna have like a side of our equation that has iPhones, and then another side with Androids. And we want to know when are the iPhones and Androids going to be equal to each other, right? So how many iPhone kids do we start out with? 287. Are we adding iPhone kids or taking away iPhone kids? Okay, increasing. So plus 6 for every year, so the 6 gets an X. Okay. What about for Androids? How many do we have with Androids? 119. Also increasing by 14 every year. So if we were thinking about this with our unit 8 hats on, we would have had to say like X is years and Y is students, right? So do you see that our output on each side is going to be students? And we want the students to be equal, right? All right, so then we would have to say Y equals 6X plus 287 and Y equals 14X plus 119. You see that I have a system right here? Okay, so we were doing kind of like systems way before we ever got to unit 8, right? Now I have y's alone. I have an expression that is equal to y that I can plug in right here, and then I get that equation. Does everybody see it? Okay. All right, so how do we solve this thing? Well, I want all of my x's on one side. Where do we want the x's? On the right or the left? Really? Okay. If we put them on the left, it's going to be negative. You guys see that? Okay, so I'd rather put them on the right. So I'm going to subtract away the 6x from both sides. Make sure that you're doing like with like terms. These cancel. In the same step, can I also get rid of that 119? So I'm subtracting away 119 from both sides. Okay. What's 287 minus 119? 168. Okay, and then is this 8? No, 8x. Okay, now what? Divide both sides by 8 and I get 21. 21 what? Years. Okay, write me a beautiful sentence. All right. So what did you guys say? You're supposed to be writing a sentence. Okay. So at what happens? Yeah. At 21 years, the number of students with iPhones will equal the number of students with Androids. All right, what about this guy? What do you guys think? Do you want to keep the ends positive or just move everything over to the left? Okay. Actually, that is actually the same thing on this one. So how do I get rid of this negative 13n? I have to add 13n to both sides. Oops, that was only 3n. Okay, I've got negative 25 equals, whoops, plus 13 plus 7n. Okay, 20n is greater than 75. Now what? It's already negative. How do I undo subtracting? I'm going to add it over. Okay, so that gives me 20n is greater than 100. Okay, now we're dividing by, okay, and n is greater than, hey. Yeah, greater than 5. Okay, so, do you guys remember how to do this? Remember that we shade where it's true. Okay, so is the number 4 going to make this true? Okay, so we're not going to shade on 4. What about the number 5? Is 5 greater than itself? What about 5.1? Is 5.1 greater than 5? Okay, so basically, wherever we put 5, we're going to have an open dot because we're not going to shade on it. But even numbers like 5.1 or 5.01 are greater than 5, so we're going to shade everything that's to the right. Okay, so this is 5, and then we'll just pick some other numbers. 4, 3, 2, 1, 0. Here's 0. 1, 2, 3, 4, 5. Here's negative 5. Questions? Okay. This problem is about cookies. It's delicious. Okay, so do we want to make exactly $200? We want to make more than. Can you guys feel the inequality here? So we're going to go more than 200. Don't forget your let statement. When we're selling the cookies for $2.50, are we earning money or spending money? Earning. Okay, what about the expenses? Like if I have to buy flour and okay, do you see that expenses come out of my earnings? Okay, so be careful. The expenses are going to be negative. Okay, go. Okay, what did you guys say for your let statement? Oops. Let, yeah, X, B, cookies. Okay. Okay. What did you guys say for your inequality? 65 plus $2.50 per cookie is what? Greater than or equal to 200. Okay, so this is like, I would say this is over halfway there. What do we know about the expenses, the $65? They're subtracted, so the 65 has to be negative. Okay, I see one other issue. Yeah, do we want to make at least $200 or more than $200? So get rid of the line under the greater than sign. Right? That was a tricky one. Okay, so let's solve it. How do we get rid of the negative 65? Yeah, doesn't it make sense that if we want to make over 265, we have to, if we want to make over 200, we've got to make over really 265 to cover our $65 worth of expenses, right? Okay. So we'll have 250x is greater than 265. Divide by 2.5 and I get x is greater than 106. So, is 106 cookies going to get us over $200? Does it say equal to 106 or does it say more than? Yeah, so really, unless we're selling half of a cookie, we're going to probably want to sell like 107. Does that make sense? 107 or more? Okay, write me a sentence. We have to sell more than how many cookies to make more than $200? Guys, number 12 is going to be homework. Yay! Okay, circle that and write homework next to it. Let's move on to Unit 2. Okay, so a lot of this we've had to use over and over and over again. So even though it was hard the first time we saw it, hopefully now it's like, riding a bike. It's easy after we wobble a second and we find our center of gravity and then we go. All right, how do I find the product of these two binomials? Yeah, distribute. If I was finding their sum, I would just combine my like terms, right? But if I'm finding the product, I'm going to have to distribute them. So I'm doing first times first. 5x times x gives me 5x squared. Good. Okay, 5x times 3 gives me 15x. All right, what about negative 1 times x? Negative 1x. Good. Negative 1 times positive 3. Negative 3. Am I done? What do I have to do? Yeah, combine my like terms. So I've got 5x squared plus 14x minus 3. Okay, how do I find the area of a rectangle? Yeah, length times width. So here I have a length and a width. What do I have to do to them? Multiply them. So if you want, you can rewrite it, or you can just distribute on here. You know what I mean? If you want to rewrite it where the 7y is in front and you distribute it, that's fine. Otherwise, just do what I just did. All right, what is 7y times 4y squared? 28y cubed. Very good. All right, what about 7y times y? Good. And then 7y times 2? Good. Okay, so for the next one, it kind of goes off of the one that we just did. We know that if we take the length and the width and multiply them together, we get what? Area. So if instead we are given the area and one of the sides, we can take the area, divide away one of the sides, and we're left with the other side, right? All right, I want you to do number 15. Go. Here's our area. Here's our width. What do we do with the area and the width to get the length? What? Yeah, divide. So I'm going to take my 9x to the fourth and divide by 3x squared. I'm going to take my negative 18x squared and divide by 3x squared. Okay, so 9 divided by 3 is 3. Okay. Now, I've got x to the 4th divided by x squared. Let's remind ourselves what happens. We've got x times x times x times x, and then I've got x times x on the bottom. Yeah, cancel, cancel, right? So I get 3x squared left. I wrote a mistake on this power. This should be 3x squared. Okay, now what? Bring down the negative. 18 divided by 3 gives us 6. What if we have x times x over x times x? What happens to all of those? Yeah, they cancel. So do I have any x's on there? No. This will just be units. Because they're linear units, not square units. All coming back to you? Okay. It has been a long time since we've done our conversion rule, but I would like you to write it here. I gave you a lot of space. So label it conversion rule. Okay, we learned this in Unit 2 to convert radicals into rational or fraction exponents. Okay, so if we have if we have a root with some index, like a root n, and we have x to the m power under the radical, what does that give us? Well, remember the x is our base, and then we have to make a fraction as the exponent. So it's just like we got to remember where the m and the n go. No. It's the other way. Yeah, it's the other way. So it's always like power out over root. So the n is telling you the root, right? And the roots go into the ground, right? So it's going to be power over root. Okay, and then there's another way that we can also write this where it's the nth root of x, and then outside of parentheses we make it the m power. Those three are all equivalent. Okay, I want you to take a couple seconds, and the numbers got a little screwy, but I want you to do the 16 and 15. Sorry that the numbers are messed up. All right, what did you get for 16? What's your base for your rational exponent? The 4? Okay, make it large and in charge, and then you're going to make the power tiny. What goes in the numerator of your power? The 7 or the 3? The 7. Okay, and the 3 goes in the bottom, in the denominator. Oh my gosh. Okay. All right, what about this one? This one is going backwards. Okay, what kind of root? Square root, good. 41 to what power? And we can simplify this as just root 41. So if we don't have a root specified, remember the default is that it's square root. If I want you to do cube root, fourth root, fifth root, I will have to put the index there to tell you what root to take. If there's nothing written there, it's square root. Questions? All right. We are going to jump into the future and come back for the second number 16. We're going to go all the way to number 12, which makes no sense. The numbers are really screwy. This big matching problem is where we're going. You guys remember this guy? Yeah. Some of you guys are still having nightmares about it. Okay, so we have to match these up. All right, look at this one right here. Do you see how I'm dividing same bases? So when I divide same bases, what does it look like is happening to my powers? I've got a 7 and a 2 and then a 5. Is it like 7 divided by 2 or what? It's not. I'll give you a hint. It's not. How can I use a 7 and a 2 and get 5? Yeah. So when I'm dividing same bases, I'm going to subtract my exponents. Okay, which rule is that? Yeah, the quotient rule. Remember, quotient tells us to divide. The tricky thing about this is it's telling us what's happening to the bases, not the powers. Okay, so this is the quotient rule. That is B. Do you see the quotient rule anywhere else in this list? Yeah. It's the third from the bottom. All right, what do you think about the second one? 10 to the 4th times 10 to the 7th gives us 10 to the 11th. Is it raising a power to another power? Or is it doing a product of same bases? Do you see it's product of same bases? Okay. It's sort of like the opposite of that one, right? All right, so which one is this? Is it A or C? It has to be A. Yeah. This one is A. What is it doing to the exponents? Adding them. Okay, do you see that anywhere else in here? Yeah. Okay, and then you can see the keyword multiplying that tells us it's product, right? Okay, third one. Yeah, this is taking a power and raising it to a power. So, what happens? How do I use half and 8 and get 4? Yeah, we're multiplying them. If you're like, I can't see it, it's got fractions, you can do, you can try this. Try x squared to the third power. Isn't that x squared times x squared times x squared? And isn't that x times x times x times x times x times x for a total of 6 of them multiplied together? Isn't 2 times 3, 6? Okay, so when you're doing power to a power, we're multiplying our exponents, even if they're fractions. We don't care. All right, that's C. Where else do we have C? Right above the other B. All right, we're coming down the home stretch. Any quantity raised to the 0 power equals 1. Yeah, that one's kind of a no-brainer. That's the 0 property. All right, what about the one after it? Also D. Good. Last two. Yeah, so you can think of it like if I have a negative power in the denominator, that means my A to the 5th wants to move to the top, right? What if I had B to the negative 3 on top? Okay, it's going to give me the reciprocal with a positive exponent. What's the reciprocal of B cubed over 1? 1 over B cubed, and the power will be positive, right? So we can either use it to move something from the denominator to the numerator or from the numerator to the denominator. I always think of it as if it's got a negative power, then it's not happy where it is. It wants to move to the other side of the fraction bar and fulfill its life's purpose, right? Okay. All right, that's E. And then last but not least, any term raised to a negative exponent is the reciprocal of that term with a positive exponent. That is the negative power rule again. Questions about those? Okay. All right, let's go back in time. So the second number 16 is where we are. So if I have 4 to the negative 2, what does that do? I get the reciprocal with what kind of power? Okay, with a positive power. So what's the reciprocal of 4 over 1? 1 over 4, and then the power is going to turn positive. Do you see any matches? Yeah, this one right here. What if I simplify 4 squared? What's 4 squared? A 16, so it could also be 1 over 16. Anything else? Okay, there's nothing else. That's it. Don't pick any of the others. The others are wrong. Okay. What about this one? So if I wanted to simplify this to get just one power, which rule would I use? Product, quotient, power to a power, 0, negative. What? Yeah, power to a power. So the power to a power rule says I have to do what with my exponents? Multiply them. All right, so I'm doing 3 times 1/2. So I ordered 3 pizzas and only half of each is left. Do you see that I could turn this into a whole pizza and that's just left over? So I've got 3 halves. Okay, so this is 25 to the 3 halves power. Now, can you convert that? Use your conversion rule that we wrote out. Think about which is the m, which is the n. Where does it go in the fraction? Which ones did you pick? The third one and the fourth one. Yep. Okay, those are correct. Can we put that in the calculator and see what we get? So go to your calculator and do 25 power caret 3 divided by 2. There's one more. It's 125 also.